Hey guys, my name is Peter and today I'll be covering Beats by Physics. So for those anticipating Beats by Dr. Dre, unfortunately that won't be happening today. So let's start by defining what a beat is. So when we listen to two waves that have slightly different frequencies, we can hear the amplitude increasing and decreasing as a function of time. This variation of amplitude is called a beat. So let's say we're in a room and we hear two waves. We can represent this using a mathematical function whereby y is equal to cosine of 2 pi times 12t plus cosine of 2 pi times 14t. Now we can compare the frequencies of these two separable functions knowing that the period is equal to 2 pi divided by omega. The period of cosine of 2 pi times 12t is 2 pi divided by omega, and we know that omega is the coefficient of t, so that's 2 pi divided by 2 pi times 12, which is equal to 1 over 12. Knowing that the frequency is equal to 1 over the period, we know that it's 1 divided by 1 over 12, which gives us 12 hertz for the first part of the function. So we can apply this to the second part of the function, which is cosine of 2 pi times 14t. We find that the period is equal to 1 over 14 and the frequency is equal to 14 hertz. Going back to our original function of y is equal to cosine of 2 pi times 12t plus cosine of 2 pi times 14t, although it is a beautiful function, we can further reduce this using a trigonometric identity, whereby y is equal to 2 cosine of the second omega subtracted by the first omega divided by 2 multiplied by t multiplied by cosine of the second omega adding the first omega divided by 2 multiplying by t. In doing so, we get y is equal to 2 cosine of 2 pi t and multiplied by cosine of 2 pi times 13t. As you can see, the blue term does have a smaller frequency compared to the red term. So the blue term, we can say that it's constant because it's less frequent than the red term. And we can call the blue term the angular frequency difference. The red term, on the other hand, is more frequent, so therefore there's more oscillations and more variation in amplitude, and it is termed as the mean angular frequency. When two waves are close to each other in frequency, we can hear a tone that has the mean frequency and whose amplitude varies by the difference in angular frequency. So going back to y is equal to 2 cosine of 2 pi t multiplied by cosine of 2 pi times 13t, the mean angular frequency, which is the red part, is greater than the angular frequency difference, which is the blue part. We can show this through graphing the angular frequency difference, and this will show the variation in amplitude caused by the angular frequency difference, which is in our case y is equal to 2 cosine of 2 pi t. So this is what y is equal to 2 cosine of 2 pi t is with respect to time. As you can see, the amplitude ranges from negative 2 to 2. I've just used arbitrary coordinates here, so this is just a representation of what it would look like. We can say that the angular frequency difference acts as an envelope enclosing the mean angular frequency, which we will see in the next graph. Now this is what the graph looks like when you combine the two parts of the function. Since the mean angular frequency is more frequent compared to the angular frequency difference, you can see that it oscillates more often and is bounded by the envelope, which is the red curve. Therefore, when hearing two waves that are close to each other in frequency, the tone you will hear depends on the mean frequency, and its amplitude will depend on the angular frequency difference. Now we can apply our knowledge to a basic physics question. A tuning fork with a frequency of 500 Hz is played along with a string on an instrument and 2 beats per second are heard. What are the possible frequencies of the string on the instrument? Before we start answering the question, we should realize that since only one tone is heard, we can assume that both of the frequencies are very similar to each other. If they weren't, then there would be two distinct tones. Therefore, the tone that is produced, which is 2 beats per second, is the difference between the frequency of the tuning fork and the frequency of the string. Therefore, the possible frequencies would be either 498 Hz or 502 Hz. This concludes my learning objects, and thanks for listening.